Today we're going to be talking about Lesson 1.4, Rewriting Equations and Formulas for Advanced Math. So today you're going to notice that all of these equations that we're talking about are going to have multiple variables. So what this is saying is that there can be multiple unknown pieces of information, but we need to specify the equation in one variable. So for instance, if you look at examples 1 through 3, it's asking you to solve the equation for y. So in all three equations, you're going to see an x and a y variable, but when you're finished solving, you want to have the y in these equations all by themselves. So I'm going to give you a few minutes to try those. After you've given those a try, come back and we will discuss them together. Okay, now that you've had a chance to look at these three on your own, we're going to discuss them. So you always, when you're solving for one specific variable, you want to start on the same side of the equal sign, but furthest away from it. So for instance, we're solving for the y, so we want to start on this side of the equal sign. So looking at the y, the furthest thing away would be to add x. The opposite of subtracting x is to add x to both sides. So when we do this, negative x plus x cancels. So we have 5y equals 10 plus x. The next thing that we would want to do to get y by itself, 5 and y are being multiplied. So the opposite of that would be to divide by 5. Now when we divide by 5 on this side, we have to divide everything on this side also by 5. So 5y divided by 5 will be y. This gets split up into two parts. Each item on this right side of the equation will be divided by 5. So 10 is divided by 5, x is divided by 5. So 10 divided by 5 is 2, and x divided by 5 you can leave as x over 5, or you could also say that that would be 1/5 of x. So now we can see this would be where we would stop because we have the variable of y all by itself on one side of the equation. So now when we look at this one, we're starting on this same left side because that's where the y is, but we're starting the furthest away from it. The opposite of 4x is negative 4x. So we're going to be subtracting 4x from both sides. 4x take away 4x cancels. It's really important that you don't lose this negative sign here or the subtraction sign. So this is a really common mistake just to forget it. We need to make sure that we bring it down. So negative 4y is equal to 1 minus 4x. Again, negative 4 is being multiplied by y, and the opposite of that would be to divide. Negative 4y divided by negative 4 will be y. And again, we're dividing each term by negative 4. So this would be 1 divided by negative 4 and negative 4x divided by negative 4. So here when we simplify, y would be equal to negative 1/4. Dividing two negatives will give you a positive. 4 divided by 4 will cancel, and we're left with x. So y would equal negative 1/4 plus x. Here again, we have the y by itself, so we know that we're finished. Here, the y is on the right side of the equation, so we're going to start over here. Furthest away on that side would be the 6x, and the opposite of 6x would be to subtract it. Again, keep in mind that you cannot subtract these two terms because they are not alike. They do not have the same variable. So this would be negative 6x plus 12 equals 3y. To get the y by itself being multiplied by 3, so we would divide by 3. 3y divided by 3 is y. Again, each term here would be divided by 3. So negative 6 divided by 3, negative divided by a positive is a negative. 6 divided by 3 is 2. So we have negative 2x plus 12 divided by 3 is 4 equals y. Again, we have y all by itself, so we know at this point that we are finished, and that y would equal negative 2x plus 4. Now, if you look at the next box, it's talking about a key idea. So the key idea here is that a formula for converting from degrees Fahrenheit to degrees Celsius is C equals 5/9 times the quantity of F minus 32. So what this is saying is when you're wanting to convert a temperature in Celsius to Fahrenheit or in Fahrenheit to Celsius, that you can use this equation. So let's go ahead and take a look at number 7. You are going to start by rewriting this equation. So C equals 5/9 times F minus 32. And it says the room temperature is considered to be 70 degrees Fahrenheit. Suppose this temperature is 23 degrees Celsius. Is this greater than or less than room temperature? So it's asking us to convert 23 degrees Celsius to Fahrenheit in order to see if it is greater than what room temperature is at 70 degrees. So we're going to take this 23 degrees Celsius and we're going to plug it in for the Celsius variable. And we will see here that now we are left with one variable, which would be the F for Fahrenheit, which is where we're going to solve. So go ahead, take a minute and try to solve this and then come back and we will work it out together. Now that you've had a minute to take a look at this, we're going to start by distributing this fraction into the parentheses. So we have 23 is equal to 5/9 F. 5/9 times F is 5/9 F. Again, whole numbers are always over the denominator of 1. 5 times 32 is 160. 9 times 1 is 9. Positive times a negative is a negative. Now, the next thing that you would want to do is add this 169ths to both sides. This side, negative and a positive of the same number, will cancel out. So now we would want to add 23 plus 169ths. But most of us probably don't really know what 169ths is equal to. So it's important here that we are going to find common denominators. So our common denominator, since 23 is a whole number, can simply equal 9. So we need to figure out 23 is equal to how many ninths? Well, 1 times 9 is 9. So 23 times 9 would be what? So when we multiply 23 times 9, you should end up with 207. So we're really going to be adding 207 ninths plus 160 ninths would be equal to 5/9 F. So now I'm going to do a little erasing here so we can have enough room to finish. Now, as we keep moving, if we add 207 ninths plus 160 ninths, we are going to end up with 367 ninths, which is equal to 5/9 F. Now, 5/9 and F are being multiplied. We should know now that the opposite of multiplication is to divide. However, we don't divide by fractions. Instead, we multiply by the reciprocal. So the reciprocal of 5/9 is simply 9/5. And keep in mind that whatever you do on one side, you must do on the other. So we can cross cancel the 9's here. We end up with 367 over 5. Again, we can cross cancel here. 9 times 5 is 45. 5 times 9 is 45. 45 over 45 is 1. So we have 367 is equal to F. Now we need to simplify. What is 367 fifths? So when we divide here, 5 goes into 36 7 times. There's 35. 6 take away 5 is 1, and you can bring down your 7. 5 goes into 7 is 3, and that is 15. And we're going to have 2 left over. So 73 and 2/5 degrees Fahrenheit is what this converts to. Now, it's asking us, is this temperature greater than room temperature of 70 degrees? So is 73 and 2/5 greater than 70? It is. So we can say that it is greater. So we know that 23 degrees Celsius is greater than 70 degrees Fahrenheit.